It's time for Chemistry, Chem 1105, with your host, me, Dr. White. It's Friday. Yay. Hope you all had a nice day yesterday. I went out and did battle with my bushes and weeds in the front of my house. I've got a huge property, and that took me about 2.5 hours. This weekend will be about 3 or 4 hours at least. I'll do my backyard, which is quite big. But the weather was so beautiful. And then last night, right about sundown or a little after, I was sitting on my back deck for a while. The weather was just beautiful. All right, now let's go to Blackboard. Thumbs up, people. You see Chem 1105, test number 1. Thank you, Amber. All right, if you look at the syllabus, sometimes, and that's why I put the term tentative, I guess wrong on timing. Sometimes I postpone things, sometimes I move it up when it comes to tests. And this is a case where I moved it up. On Friday, a week from today, I will be giving test number 1 online during our Zoom meeting time, meeting starting at 10 o'clock. You'll be downloading a password protected PDF file for test number 1 from the assignment area Blackboard that will be available on Thursday, sometime Thursday afternoon. I'll post that as test number 1 assignment with the PDF file. And actually, there'll be more than one, and you'll see why. On Friday, around 9:55, give or take a minute or so, I will send out via email the password for the version of test number 1 PDF file that you should take. Usually I make 2 versions. It cuts down on cheating. And you will have until 11:30 that Friday to finish test number 1 and upload test number 1 answers to the assignment area Blackboard. Most of my tests, the way they're designed, and it is, if you've done the practice problems and studied, you should be done in about 35, 40 minutes. Yeah, but I'm giving you an hour and a half because you also have to scan and upload it. Now, if you do not have a printer, you can handwrite the answers. You don't have to recopy the questions on a piece of paper. Either scan it with a scanner or use your cell phone, take a picture and convert it into a PDF file. Test number 1 will cover the material in chapters 1, 2, 3, along with the material in appendix 2A and or A2 and 4A4 in our textbook that we've already covered in class. Test number 1 is 100 points, has 29 problems. Relax. My tests are designed so you shouldn't have trouble finishing in a lot of time, which we're in face-to-face would be 50 minutes. Almost all students on test 1 finish early. And it does include 7 multiple choice. The rest are short answer. It has 8 pages, which includes a page which I've already shown you in the lecture section called Key Formulas. There will also be the periodic table, the green one I've shown you, for you to download, and that's the one you should use while taking test number 1. Now, if you haven't done so, and most of you have been able to do it correctly, please read the files on how to take and upload a test for 1105 that are available on Blackboard. And in the first 2 labs, you can see those for downloading. It's also how to do a lab. On the Wednesday, next Wednesday, I'll do my world famous review for the next test, test number 1, in our Wednesday Zoom meeting. And that, students tell me, helps them. And I want students to do good because it makes me happy, which is something I like to do. And I'm sure it makes you happy if you do good on a test. So that's test number 1. Are there any questions about test 1? I guess not. But always feel free. You can email me, or you can also come to my office hour to ask questions about anything. Remember, in my class, and realistically in my life, there's no such thing as a dumb question. And by now, I think a lot of you know, I practiced that. All right, I promised today we'd go through chapter 3, problem set. And with that, will have covered all the problem sets and all the material for test number 1. And one thing I should mention about my test, every question on my test, everyone, I have covered the concept behind that question at least twice in lecture, usually a lot more, but at least twice. All right, everybody see chapter 3 practice problems on your screen. Thumbs up, people. Thank you. All right, let's go through this. These are things you should know. What are the 3 subatomic particles of an atom? The electron, proton, neutron. You should know. What's the charge on a proton? It's a positive charge. What's the charge on an electron? It's a negative charge. And I don't have it there, but what's the charge on a neutron? No charge. Now, I've got to do something real quick. Actually, wasn't that real quick? All right. Now, next question. How many electrons and protons do each of the following elements have? Well, how do you do that? Well, you look at your friendly green periodic table. And the atomic number, the number in the upper corner of the periodic table, upper right-hand corner for this one, some of it's in the left, but this one's on the right. The atomic number tells you how many protons, how many electrons are in an element. So if we go back to the table, how many electrons and protons are in carbon? Well, carbon, and I'm sneaky on this question because you also have to know the chemical symbol, C, atomic number 6, therefore it has 6 electrons and protons. And if we go to, let's look at a dangerous one, mercury, Hg. And if we look over here, Hg, atomic number 80, atomic number tells you how many protons, how many electrons. And if we look, I got it right, 80 and 80. And finally, potassium K, where do we find that? And that's an alkali metal, atomic number 19. Atomic number tells you how many protons and electrons an element has. And 19 is the correct answer. All right, next one. Write the electron configuration for nitrogen. Remember, electron configuration tells you which subshells and shells electrons are in. So how do we do nitrogen? Well, first of all, you have to find out how many electrons. Remember, electron configuration is for all electrons, not valence electrons. And one of the things I don't have open, so I've got to go open it up. All right, thumbs up, people. Do you all see important information? Test one. Thank you. Thank you, Alyssa. Are you going to put a little emoji on your thumb?
I don't see it actually, sorry.
Oh, okay. Well, you're right. Let's do it. Now do you see it? Thank you for letting me know. That's a problem with Zoom. Zoom tells me you should see it, you being just other people on Zoom, and you can't. And that's why I came up with the thumbs up, people. All right, you should review this. Let's go through it. The electron shells, shell 1, 2, 3, and 4. And remember, this is the lowest. We're talking about energy. Lowest, this is the highest. And you should know shell 1 has 1 subshell. Shell 2, 2, 3, 3, 4, 4. Now, each subshell has a letter, and a subshell actually is a number and a letter, but each shell has subshells, and they're all the same. And again, energy. This is the lowest, S, and the highest is F. And why am I writing this down? One, so you learn it if you haven't. And two, when you're filling electrons, you always fill the lowest shell and subshell first before you go to the next highest energy. So we always start with 1, fill that, then go to 2, and so on. And each shell, you start with S, then P, D, and F. Now, we're trying to do nitrogen. And nitrogen, if you look up the atomic number, it's 7, tells you it has 7 electrons. The first shell is 1. It has 1 subshell, which is 1s. Remember, a subshell is a number, a letter, the name. And how many electrons can you put in any s orbital? Oh, I forgot. I can look at the table. And the answer is 2. And therefore, and while I'm here, remember shell 1 has 1 subshell, which is 1s. And now I'll put my 2 electrons, but I have 5 more to go. What's the next shell? That's 2. Now in 2, what's the first subshell? Well, in case you forgot, it's still S. And the second one is P. Now remember, in S, any S, 1s, 2s, 3s, you can only put 2 electrons. However, in P, we can put up to maximum, this should be maximum number of electrons, you can put up to 6. So let's go back at what we were working on. We put in 2 electrons in 1s. One only has 1 subshell, 1s. We filled it. Now we go to 2, shell 2, and the first subshell is 2s, which again, we can put in 2 electrons. Well, 2 plus 2 is 4. 7 minus 4. Isn't the math tough in this class? 7 minus 4 is 3. Well, if I filled up subshell 2s, 2 has 2 subshells, and that second one is 2p. Now I can put up to 6 electrons in 2p, but I only have 3 more to go, so I'll put it in there. So the answer is 1s2, 2s2, 2p3. Don't tell anybody, but remember my gift to you. It's a nice gift. And that is for test 1 and also the final. for this type of question, electron configuration, you only have to know how to do up to 12 magnesium. Why? Because when you get much higher, you have a lot of exceptions to the rules. Instead of having you spend a lot of time memorizing these exceptions, I'd rather teach you more important things. And can you keep a secret? I don't remember the exceptions because valence electrons are more important. All right, know something? I'm going to let you try one. Let's do sodium. And I'll tell you that has 11 electrons. And I will be real nice and show you the tables which are available to you in the important information test number 1. So have some fun on this Friday afternoon or morning. Wow, I've been up so long, it seems like an afternoon. I don't know what time you start your day, but by about 5:30, I was already on my computer doing work. That's 5:30 a.m. All my life, I've never needed much sleep. Usually I go to bed about 10:30, 11 o'clock, and I'm up by 4:30, 5 o'clock. Used to cause a lot of fights with my mother because she said, go to bed. It's 9:30. I said, it's too early. I'll be up at 3 in the morning. Finally, we agreed, all right, you can go to bed at 10:30. That's when I was about 8 or 9. We already were having those fights, probably earlier. Remember, you have sodium, 11 electrons. And don't forget, Monday is National Turn on Your Webcam for Dr. White Day. And when you're up, done, vote. Or I guess you can give me a thumbs up too. Let me try something. I don't know if everybody saw the Let's relaunch it. There we go. For some reason, it didn't kick in. All right, I think everybody's done, so I better get to work. Let's do sodium. How many electrons do we have? 11. So therefore, the first shell is 1. All right, what's wrong with my pen here? This is not good. There we go. Oh, I know what's wrong. I didn't have ink in the pen. 1 and the first and the only subshell, lowest energy, is 1s. Any s orbital, not orbital shell, subshell, you can put 2 electrons. 1 has 1 subshell, 1s. We filled it. Now we have to go to 2. The lowest energy subshell in 2 is 2s. How many electrons can we put in any s orbital? And the answer is 2. Now, if you look at important information, which we're going to do, shell 1 has 1 subshell, which has a maximum of 2 electrons. Well, when we fill that, we go to 2, and the lowest energy we fill first is 2s, and then we go to 2p. And notice 2p, I can put a maximum of 6 in. And so let's do that. So 2 has 2 subshells, 2s and 2p, and I can put a maximum of 6 in there. But I have 11, and 11 minus 2 plus 2 plus 6 is 10. I have 1 more electron to go. Well, if you look at shell 2, and we're going to do that right now, you only have 2 subshells, and we filled it up. So now we have to go to shell 3. And the first subshell of 3 is 3s. Remember, an actual subshell of a shell is a number and a letter. And 3s, I can put in 2 electrons, but I only need 1. So the answer is 1s2, 2s2, 2p6, and 3s1. And that's how you do it. And the others are just the same. And finally, on the last page, it asks how many valence electrons do the following elements have? And before I ask that question, there's another one I should have asked on that problem set is, what are the valence electrons? And you should know that the valence electrons are the outermost electrons of an element or the atom of an element. They're the outermost, and they're most fun to play with because those are the electrons involved in making chemical bonds for chemical reactions. Now we're really talking about fun stuff. Yep. So you should know valence electrons are the outermost electrons of an element. If I ask how many valence electrons does hydrogen have, carbon, oxygen, iodine, oh, I even put down my favorite, not really, even though I like to say the joke about krypton, which you've heard. What are those valence electrons? And how do you do that? You go to my periodic table that I will provide to you. And for test number 1 and 2, 3, 4 in the final, and you look at the number at the top of the column. The number, either Roman numeral or in red, the numeric number, tells you how many valence electrons each element in that column has. Column, in case you're not familiar, up and down here. So the first one I asked was, I don't need this, hydrogen, then carbon, hydrogen H, number is 1, carbon 4. Oh, let's do one that's not on there. How many valence electrons does sulfur have? Time's up, sulfur S, look at the top, 6. Oh, let's do another one now. This is one of my favorite elements because I used it a lot in grad school when I was getting my PhD. And that is argon. How many valence electrons does argon have? Time's up. Argon, chemical symbol AR. It's a noble gas. It's right here. Look at the top, 8. And finally, let's do another one of my favorites, chlorine. How many valence electrons does chlorine have? All right, put down your pen and pencil, hand in your computer. The bad joke, really bad joke. Anyways, chlorine, chemical symbol Cl. It's a halogen, this column. Look at the top, 7. And that's how you do it. Are there any questions for any of the material I just covered in chapter 3, problem set? I guess not. And thank you for those who turn on your webcam. I'm talking to real people. But anyways, all right. That covered all the material and problem sets for test 1, which is a week from today. But let's go on. Oh, there's an important public service announcement from Dr. White. About 6 of you haven't signed and uploaded the problem set, not the problem set, the signature sheet. Please do. I'll be sending out an email over the weekend to you if you haven't. Also, another important public service announcement from me, and that is before you upload your lab or in this coming Friday, your test, check that one, it's a single PDF file that you can open it, which 2 of you, I couldn't open your PDF files. I'll be sending you an email for the density lab and you'll have a chance to resubmit it. And also some of you, make sure you've answered all the problems. And also make sure your upload has all your answers. Please do that. You don't want to lose points by doing that. And I don't want to take off points for doing that. All right, since there are no more questions on the problem set, it's time to continue with chapter 4. Remember, this will be on test number 2, not test number 1. All right, now on Wednesday, I was talking about multiple covalent bonds. And you should know there's a single bond, a bond in which 2 atoms share 1 pair of electrons, double bond, a bond in which 2 atoms share 2 pairs of electrons, and a triple bond, a bond in which atoms share 3 pairs of electrons. So it's Friday, so I better be subtle. And what should you know? One of these days, I'll practice drawing straight lines on a tablet. Just pretend they're nice and straight. All right. You should know single bond is one pair of electrons being shared. Double bond, two pairs of electrons being shared. And triple bond, three pairs of electrons being shared. Again, you should know this. A double bond, a single bond, skip one, single bond, one pair of electrons being shared. Double bond, two pair of electrons being shared. Triple bond, three pairs of electrons being shared. Now, let's do some practice. We did nitrogen. Let's do a couple more. Oxygen. I'm going to let you try this one. Now, remember the octet rule. And the thing you have to look is how many valence electrons. And each oxygen has 6 valence electrons. And why don't you try that? Then I'll do it and show you how to do it if you forgot. Remember, single bond, one pair of electrons, double bond, two pair of electrons, triple bond, three pair of electrons. Ooh, I'm brainwashing you. Hopefully you won't have any nightmares hearing Dr. White says, double bond, two pair, single bond, one pair, triple bond, three pair. Now, if you're done early, I try and give everybody time to finish, so please be patient. All right, looks like everybody's done, so I better get to work. All right, each oxygen has 6 valence electrons. Now, the way I'm doing it, you don't have to, but it helps students see. This oxygen says, oh, look, I have 2 unpaired electrons. You've got 2 unpaired. Let's share it. Now, the non-bonding electrons come along for the ride. So 2 electrons from here, 2 electrons from here, and the non-bonding electrons are still there. So in the oxygen gas that you're breathing to keep you alive, what kind of bond, chemical covalent bond, keeps the 2 oxygen atoms together? And if you look at it, 2 pair of electrons, that's a double bond. Now, remember the octet rule. Atoms of elements gain, lose, or share electrons to have an octet, 8 valence electrons. The only exception is hydrogen, its octet is 2. So if we look here, this oxygen here, how many dots do you see? 2, 4, 6, 8. It's got an octet. And if we look at the other oxygen, how many shared and unshared electrons are there? 2, 4, 6, 8. Guess what? They both have their octet. Now, if you happen to be at any football parties this weekend and you see someone breathing, you can go up to them and say, hey, do you know the oxygen you're inhaling has a double bond in it? That's 2 pair of electrons. People don't like hearing chemistry at football parties. All right, let's do another one. Hydrogen cyanide. Now, I'll help you out. Hydrogen has 1 valence electron. You know how to look this up. Carbon has 4 valence electrons, and nitrogen has 5 valence electrons. Now, I'm going to give you a big hint, which I will not do on a test, and that is in this molecule, carbon is in the middle. And have fun. One of these days, I have to bring in a recording of game show music, like when they ask a question and the contestants are thinking they play it, like dun, 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 dun. I'm not going to ruin your morning. So everybody slam off their speakers when I start singing. Me too. It's not one of my skills in life, being a good singer. All right, let's check how people are doing. One of the hard things in Zoom when people have their cameras off is I can't tell if you're done. In a classroom, I can see the class, and I also tell them, when you're done, look up and smile, even though you don't have to. And it looks like everybody's done. So I better get to work. How do you do this? Hydrogen has 1 valence electron. Carbon has 4, and nitrogen has 5. So the hydrogen says to the carbon, I have 1 valence electron, you have 1, let's share. And they do. Now that's spoken for. And the carbon looks at nitrogen and says, look, I have 1, 2, 3 single valence electrons, unshared or unpaired, and you have 1, 2, 3 single or unpaired electrons. Let's share. And the carbon has 1, 2, 3. The nitrogen has 1, 2, 3. And the non-bonding pair of electrons come along for the ride. And by the way, you could have put it on this side, the non-bonding, or there. Organic chemists usually put it, like I do, on top. And that's the Lewis structure for hydrogen cyanide, a very deadly poison. And if we look at it, first of all, can you name the type of covalent bonds in that molecule? I'll give you 18.7 seconds. Go. Time's up. One pair of electrons being shared, single bond. Three pair of electrons, 6, 2, 4, 6. That's a triple bond. So in hydrogen cyanide, HCN, there are two chemical bonds, a single bond and a double bond. And if we look at each atom, I'll start with hydrogen. It has 2 electrons, shared or unshared. Actually, they're only all are shared, and that's its octet. Remember, the exception to the octet rule is hydrogen. Actually, I should have drawn this one right here. And next, let's look at carbon. Carbon, look everything in the green box, 2, 4, 6, 8. It has its octet. And the last one, let's go to blue. We look inside the blue box. Nitrogen has 2, 4, 6, 8. It has an octet. Now, let's do a polyatomic ion. And that's potassium cyanide. And potassium has 1 valence electron, carbon 4 valence electron, nitrogen 5 valence electrons. And remember, for this one, carbon is in the middle. Have fun. Your turn. And while you're doing that, I can get something ready. All right, I think everybody's done. I better get to work. Now, let's look at potassium. And in order to do that properly, I have to go to our periodic table. Except for hydrogen, the alkali metals, which hydrogen is not, the first column, and the alkaline earth metals, the second column, always form ionic bonds. What ion will potassium form? A +1. So therefore, I can immediately do this. Now, carbon has 4 valence electrons, nitrogen has 5. And carbon says to nitrogen, I have 3 unpaired electrons, valence electrons, you do. Let's form a triple bond. Oops. And they do. And now we look at this. Let's check the octet rule. Here, nitrogen has 2, 4, 6, 8 electrons. Hey, it's pretty good. It's got its octet. And if we look at carbon, it has, 2, 4, 6, 7. That's not an octet. What do? Well, where did this valence electron from potassium go to leave it as a +1 charge? And the answer to that mystery is it went here to carbon. This is now a polyatomic ion with an extra electron. So it's got a negative charge, and that's the structure. What type of chemical bonds are there in potassium cyanide, KCN? And the answer is an ionic bond and a triple bond. And remember, all alkali metals, potassium, sodium, lithium, all alkaline earth metals for this class, that means calcium and magnesium, always give up their electrons to form an ion. And potassium, sodium, and lithium, it's always a plus. Calcium, magnesium, +2. And remember that. All right, next couple of slides, I'm going to turn the switch. Will this be on a test or a final? To click off, but something I do want to cover, and I'll start it today and finish it on Monday. And that's molecules have shapes. So do ions, but molecules. And how do we determine that shape? By the VSPER theory. And again, switch is off. All right. Something weird has just happened to me on, there we go. And if you go to Wikipedia, again, the switch is off. VSPER theory is valence shell electron pair repulsion theory, VSPER. Again, I'll never ask this on a test, but what happens is when you have a molecule, the electron pairs want to be as far apart from each other as possible because opposites attract, but the same things repel. That's why it's called the repulsion theory. And based on how many pairs of electrons, valence electrons, atoms of molecules take on their shape. And if I look at the clock, we're about done. So I'll have to continue this on Monday. Now, remember, do you keep up with the labs? Make sure you've been handing in the labs. Most of you have. Probably by tomorrow morning, I'll be posting in Blackboard the density lab scores. And they're pretty good. You guys are doing good. Thank you, making Dr. White happy. And don't forget, do the practice problems if you haven't, so you do good on test 1. And with that, I'm going to say, have a great weekend. Stay safe, wear your mask. If you haven't been vaccinated, get vaccinated. And gang gesund. Goodbye. Have a great weekend. Bye now.